Send you later. Okay, so what we have to discuss today is formula, all type of formula. So I'm starting from alkane and alkene. Alkane and alkene. We can do these two things together. So we are going to discuss alkane and alkene. Means single bond and the double bond. Alkane and alkenes, I mean, you should know that they are hydrocarbon. They are hydrocarbon. Alkane and alkene are hydrocarbon, contain carbon and hydrogen only. All right, let's move to next topic now. So let's select any alkane. For example, let's draw the structure, then we can discuss everything about it. See. Oh, we can start like this. Wait, we can start like this. Because we have to discuss every type of formula. So I'm starting like C. I have a name of alkane in a mind. For example, let's start with the easiest one, butane. Can you tell me how many carbons are there in butane?
4 carbons.
Okay, so what will be the molecular formula of the butane? You have two options. Either try to draw its displayed formula so that you could find number of carbon. You could find the formula, or you can start with the journal formula of the alkane, which is CN H2N plus 2. This is the journal formula of alkanes. So butane, this is alkane. This is not butane. So it means you can put the values. Butane contain 4 carbon. So C4, H2N. So 2, 4 plus 2. You are getting C4, H10. This is the molecular formula of the butane. This is molecular formula of butane. Okay, then what is empirical formula? They may ask you about the empirical formula. Empirical formula is not the real formula. It can give you the simplest ratio of the element in a compound. So the empirical formula in this case could be, what could be the empirical formula? You can take the simplest ratio. You can use table of 2 here. So C2H5 is the empirical formula. We don't have to use empirical formula anywhere except when you need the ratio of the elements, which are giving you a butane. Okay. The next one, we have done with the molecular formula and the empirical formula. Okay, so let's draw some displayed formula. This is not a structured formula. This is displayed formula, because whenever they ask to draw some, you can say, whenever they ask you any student to draw a structural formula, so everyone give the displayed formula. So what is the displayed formula? In which there is a detail of bonding. Okay. So what is the displayed formula? You have to draw 4 carbon here. See, 1 carbon, 2 carbon, 3 carbon, 4 carbon. Since this is alkane, means butane, no double bond will be there. So you can fill the rest of the bond with the hydrogen. Let me change the color. Now see, this is the displayed formula. I'm not writing H for the hydrogen to save the time. Okay. So you can see there are 4 carbons, C4, and how many hydrogen are there? You can count these red bonds. So 4 plus 4, 4 plus 4, 8, 9, and 10. H10. You can see I'm getting the same formula. Like I just where is this? Is I just found the molecular formula by using journal formula of the alkane, and I'm just getting the same formula by displayed formula. So this is called the displayed formula. Okay. Then what is structural formula? A structural formula is that formula which can be made just according to the structure, you can say. This is the easiest way by which I could define this thing. Okay, so for the structure formula, you can say C, this portion, H3. Then C, H2. Then C, H2. And then C, H3. This is a structural formula. This is a structural formula. But I mean, this is also acceptable, but you have to simplify it a little more, you can say. You can see CH2, CH2. So you can do like this, CH3 and CH2 in the middle, which is twice, and then CH3. This is more good. Otherwise, that one is also acceptable, but this one is more good. Is it clear? Now,
It's clear to me.
okay, now what is a skeletal formula? A skeletal formula. Okay, skeletal formula. So for the skeletal formula, see, 4 carbon, 1, 2, 3, 4. This is skeletal formula. That's it. You don't have to show any carbon. You don't have to show any hydrogen. Sometimes we have to show hydrogen. That is another case when you have to show the functional group. In aldehyde, how do we recognize aldehyde? By checking double bond with oxygen and single bond with hydrogen. In that case, you have to show hydrogen, but here you don't have to show hydrogen. I mean, this is confirmed. This is butane. There would be carbon and hydrogen. You can check 4 corners. This is butane. Now, for example, I'm just changing butane from butene. Everything will be changed. Now I said that now I'm saying that there is butene, not butane. What will be the molecular formula? This thing will be changed definitely. The journal formula is totally different. So, okay. So what is the journal formula of, because butene is alkene. So what will be the journal formula of alkene? CnH2n. That's it. This is the journal formula. Okay. The other thing is, now you have to write the formula in butene, 4 carbon. So C4, H2n means 2 multiplied by 4 will give you C8. This is formula of butene. And what could be the empirical formula? C1, H2. You can see the difference. This is butene now. This is butene, alkene now. So the first one is journal formula of alkene. The second one is a molecular formula of alkene. And the third one is empirical formula of alkene. Okay, now let's move to another one. Now we have to check the displayed formula. Definitely the displayed formula will be changed. So instead of making the whole change, let's change the bonds. Okay. This thing will be changed also. Okay, so this is butene. You have to make 1 double bond. It's up to you. Let's make double bond here. This is butene. Now fill the hydrogen. This carbon, 3 unpaired electron, 4. This 1, 2. What about the second one? Already it is making 3 bond. This. The last one, this hydrogen and this. You can see I'm following the shape of molecule right now. So, but I'm not completely following the shape of molecule. The shape of this chain will change from here, like this, this, this. It will be like this. Trigonal planar now, so the shape will be changed. The actual shape will be this. You can check your past papers. So you should know what about, you should know about the shape of molecule correctly. Okay. Let's don't waste time on the shape of molecule right now. Okay, so this is, all the red bonds are hydrogen. You can count the red bonds, 1, 2, 3, 4, 5, 6, 7, 8. So we are getting the same formula, C4H8. It means we have made a structure correctly. Okay, next one is a structural formula. What is this one? This is displayed formula. This is displayed formula. Okay, and now we have to make a structural formula. What is a structural formula? For a structural formula, definitely you have to trace all the bonding, but now you can see there is double bond also, and definitely you have to show double bonding also. So see what you are going to do. CH3. Okay. Then there is CH2. Okay. CH2. Then there is some issues. See, here we have a double bond. If you say, Miss, we can write CH, and then you have to show double bond, and there is CH2. Okay. But wait, this is CH2, the next one. I have written CH2. This is CH2. Okay. So let me tell you one thing. Hydrogen never make double bond. And your structure formula is showing that hydrogen is making double bond with the carbon. So instead of doing like this, you just have to change the place of hydrogen and carbon. Instead of CH, you can write HC here. This is structural formula of butene. And what is the skeletal formula of the butene? The same as butane, but there is a double bond. Where is the double bond? This is first carbon, this is the second carbon. So this is first carbon, this is the second carbon. Here is a double bond. This is the skeletal formula of the butene. So simple. Is there any confusion?
No, it's clear to me.
I'm just going to add few functional groups here. Now see, what we can change. Forget about the butene here. Forget about the double bonding here. Okay, and forget about this structural formula. And forget about this one also. Now see, for example, if I'm giving a structure like this, there we have CH3. Actually, we have one more carbon here, but we have CH3. You know what is CH3? Methyl, alkyl. We had discussed yesterday, I guess. Alkyl, this is alkyl. Methyl, if you are making ethane a free radical, so ethyl, pentyl. So this is methyl. Okay. For example, that's it. For example, this is, and definitely the rest of the bond will be filled with hydrogen. Okay. What is the molecular formula of this thing? 1 carbon, 2 carbon, 3 carbon, 4 carbon. Okay. So C4. And 1 hydrogen, 2 hydrogen, 3 hydrogen, 4, 5, 6, 7, 8, 9. H9 and CH3. We usually mention functional groups separately, so that just by looking at the formula, I should know, okay, this is simple alkane with a methyl group. Usually we show functional groups separately. You don't have to all the functional groups, hydrogen and all the carbons together and just give your answer in terms of C and H only. No. Molecular I mean, this is organic chemistry. No, organic chemistry is more about explained structure, detailed formulation. So actually, you have to write like this. This is the molecular formula of this thing. But what is the name here? This is not butane. This is methyl butane, because methyl is attached here. So this is methyl butane. But you can see, I mean, if you say, Miss, I have a methyl butane. So how do I know that where is methyl? You know, if you are changing the position of these functional groups, the properties will be changed. That's what we have to discuss in isomerism. There is much detail in isomers of this thing. I mean, in A levels, you have to discuss isomers in detail along with the chemical and physical properties. Okay, so I mean, you have to tell the number of carbon also. So usually we start from left side, but there is one more rule. We always start numbering the we always start giving the numbers to the carbon where the functional group is near. You can see the functional group is near from the left side. So you can start giving numbers to your carbon from the left side. But still, if you are following the other rule, means if you're still giving numbers to the carbon from the right side, that is also okay, because I have seen this one also, but it's more good if you can follow the rule. So instead of left side, we can start from the right side. First carbon, second carbon, third carbon, fourth carbon. So you can say, Miss, this is 2-methyl butane. This is 2-methyl butane. This is not simple butane. This is 2-methyl butane. Now, what is, I mean, we just discussed the molecular formula and the name, because name is very important. Now, uh, what will be the skeletal formula? Because this one is displayed formula. Okay, so skeletal formula, you just have to trace. See, CH3. Now there is a functional group. So there are a few rules which you have to follow. CH3. Then we have CH. See this one. We have CH because at the lower side we have hydrogen now. So we have CH, and in a bracket you have to write CH3. What does it mean? Methyl is attached here. Then we have CH2, and then we have CH3. This one is a structural formula of 2-methyl butene. And what about the skeletal formula? Okay, so for the skeletal formula, let me do like this.
Could you please repeat the structural formula?
Yes, why not? Wait. Let me change the color so that it could be visible to you. See, what I did actually, this is CH3. This is the last carbon with 3 hydrogen. This is CH3. So I am drawing here serious CH3. Simple. And let's focus on the second carbon. Upside, we have methyl group, and what you can see, 1 bond upside, 2nd bond left side, 3rd bond right side, 1 bond lower side with hydrogen. So actually this is CH, but methyl group is attached. So you have to write methyl group in a bracket. Means the second carbon has methyl group. Then you can move to the 3rd carbon. Above, upside we have hydrogen, and downside we have hydrogen. So it will be CH2. It will be CH2. And what about the last carbon? CH3. This is, wait, let me check. Let me show you with the blocks so you could see. See, this is, oh, let me change the color. This portion is CH3. You can see CH3 is written. Then next portion is CH, because there is hydrogen at the lower side and there is methyl group and upside. So I have to write like this. And then we have CH2, and then we have CH3. This is a skeletal formula. Is it clear now?
Yes.
Okay, what is, what other thing we have to discuss? Yes, what is the skeletal formula? This is butane now. So, oh, yes. 1, 2, oh, forget here. See, 1, 2, 3, 1, 2, 3, 4 carbon. Okay. And there is methyl group. Where is the methyl group? On a 2nd carbon here. You don't have, I'm just mentioning for you that this is for CH3, for the methyl group. But you don't have to write methyl group here. You just have to make an arrow. Oh, sorry, you just have to make 1 line, because this line is representing about 1 more carbon. Let me show you one thing here. Wait. Let me show you. Let me make it more easy for you. See, this is 1 carbon. This is 1 carbon. This is 1 carbon. This is 1 carbon. There is 1 more carbon with the 2nd carbon upside. So you have to make one more bond of the carbon. This is the skeletal formula. The skeletal formula is really tricky sometimes. Is it clear now?
Yes.
Okay. Wait a little. Okay, let's move to next structure. For let's still, I'm still trying to move in alkane and alkene. Then we will move toward alcohols. Okay, so for example, we have this one. And here we have this one. Okay, what will be the name? I'll change this structure after this example. Okay, what will be the name? This is, you can say how many, I mean, you know very well that rest of the bonds are filled with hydrogen. I'm not drawing the hydrogen bonds here. I mean, these bonds are hydrogen. 3 hydrogen here, 1 hydrogen here, 1 hydrogen here, 1 hydrogen here, 1 here, 1 here, 1 here, 1 here. Okay, so what will be the name? Or you can write molecular formula first. For the molecular formula, I'll get 5 carbon in a chain. You have to check the chain only. 5 carbon in a chain. So C5. You have to count rest of the hydrogens. You have to count rest of the hydrogens other than the CH3 molecule. So see how many hydrogen do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. And other than this, we have one more thing. 2 CH3 groups. This is the molecular formula. This is very similar to the structure formula, but this is how you have to mention it. There are a number of ways by which you could mention your molecular formula. Is totally up to you. But this is more good when you show functional groups separately into the molecular formula, because whenever I see this molecular formula, so I would know that this is C5H10, means this is something like pentane. C5H10, this is something like pentane, and there is methyl groups attached with the pentane. So this is the benefit if you're showing your functional group separately. This is more good. For example, acha, wait. What is this? This is displayed formula. Now you know very well. This is molecular formula. What about a structural formula? Then we will write the name. Structural formula is, wait, you have to focus on this. What is this? CH3. CH3. Then this one. This carbon has 1 hydrogen downside now. So this is CH, and in bracket, you have to mention CH3. What does it mean? It means methyl group is attached. Again, there are a number of ways by which you could mention your skeletal, structural formula or the molecular formula. It's totally up to you. This is more good way. Then after that, we have carbon. Oh, there is one more methyl. So CH again, because hydrogen is attached upside. This one, there is hydrogen, and downside we have CH3. I have less space, so I'm writing other thing here. This is CH2. So you have to continue the formula. CH2. And then we have CH3. This is the formula. What you have to do, wait, let me give you a trick. What you have to do, you just have to divide your structure according to the carbon. 1 carbon, CH3. 1 carbon, CH, CH3. 1 carbon, CH, in bracket CH3. Another carbon, CH2. Last carbon, CH3. That's what I did here. Yes, any confusion?
No.
Okay. The next thing which is here is, what else is remaining? The name. First, we have to write the name, then we can move to the skeletal formula, because we have to name the carbon chain together. 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. You can start giving number to the carbon from the right side. Otherwise, you can see the functional group is very near from the left side. It will be more good if you can give number to the carbon from the left side, because the functional group is very near from the left side, you can say. 5 carbon, pentane. Yes, this will be pentane because there are 5 carbon. But 2 methyl groups are attached, so I can write methyl. I can write methyl here. But you can see methyl, you can see the methyl one. 1 methyl is here at the 2nd carbon, 3rd methyl is here at the 3rd carbon. So you have to say 2, 3 methyl pentane. 2,3-methyl pentane. You have to mention the number that where you have a methyl here. What is the structure now? The structure is really simple. I mean, the skeletal formula, sorry. Pentane, 1, 2, 3, 4 carbon, 5 carbon. Now a double bond, okay. But there are CH3. Second, third. Oh, it should not be like this. See. This is, I'm unable to, okay. So this is simple, 2-methyl pentane. Yes, this is the formula, a skeletal formula. You can see these skeletal formula in your past paper. For example, is there any confusion?
No, it's clear to me.
Okay, so I'm making the chain a little more difficult. We can attach some, we can move to haloalkane also, no? So that you should know how to name a compound. But wait. There is one more myth. I mean, I'm always starting chain like this from downside using this. Sometimes you can see the chain, they are starting chain like this also. Reason? Let me show you. Carbon, one more carbon, one more carbon, one more carbon. For example, here we have CH3. So you can give your structure like this. Acceptable. For example, I have butane, but the methyl groups are here. Now, how you are going to give the name to the chain? You will not say that there are 2 methyl groups attached. No. You know, whenever you are giving name to the chain, so first you have to pick the longest chain. First you have to check that what is your chain. If you say, miss, this is my chain only. No, you can see this could be a chain and this could be a functional group only. Or you can say that, miss, this is my chain. I mean, you have to check this thing all the time, that which from where you are getting the longest chain. So you can check this, and this is your you can say this is your functional group now. So there are not 2 functional group at left carbon. There are not 2 functional group here. So see, what will be the skeletal formula? Now this is pentane, because we are counting this carbon in a chain. So this is pentane. So you can give like this also. I mean, both are acceptable. It's totally up to you. 1, 2, 3, 4, 5 carbon. And wait, we are considering this functional group, which is upside. Okay, so we have to draw it like this. Wait, then we have to draw it like side. 1, 2, 3, 4, 5, and this is my functional group. But for example, if you say, no, miss, I am not following this one, so you can go like this one. I mean, I'm following this chain, which I'm marking with the blue one. If you are following this one, then you have to draw your skeletal formula like this. Because now 1, 2, 3, 4, 5, because now this one is a functional group now. See. So sometimes you have to start your chain like this, and sometimes you have to start your chain like this. It depends that where there are functional group in a chain. Is that clear to you?
Shouldn't this be attached to the first carbon?
Wait a little.
Like the line.
Wait. This is the first carbon, which I'm making it here. Give me a minute. What I did here? No. Wait. If you wait, which one you're picking? For example, let's discuss this one. You said it should be attached with the first carbon. For example, let's pick this one. Let me show with the black one. I am following this chain. this long chain. That's why I'm saying it pentane now. I said you have to pick the longest chain. So I'm taking this carbon in a chain. So this is first carbon, this is second carbon, this is third carbon, and the functional group is attached with the second carbon. Are you getting my
Oh,
point?
I understood. Yes.
Okay. Or if you are taking this carbon in a chain, this one. So if you're following this longest chain, so you can see this lower CH3 methyl group is still attached with the second carbon. So that's what I did here. So there, I mean, you always have to follow the longest chain of